Okay, so let's go ahead and do type 4, which is the last type of equation. And this one is going to have multiple logs. Okay, so basically, we are going to have an equation that can be simplified down to one log, right? Multiple logs, and in this case, exactly one log on both sides of the equation. Now, in this particular case, we're still going to be looking at our PEMDAS for solving, and we're still going to exponentiate. But what happens, right? So I'm exponentiating, so I'm turning both of those pieces into exponents, and then our inverse property applies, and we end up with just these inside pieces of the logs equaling. Okay, so if we can get the same base on both sides, then we can exponentiate and simplify. So what we're going to do is use properties to condense each side to one log. Now there's a potential that we already have one log on both sides. And there's a little catch here. Check for extraneous solutions. You say, gosh, Miss T, we've gotten to 3 types of equations. Why haven't we checked for extraneous before? Okay, so log of x has a restriction. See this? X must be greater than 0. So when we are solving, because we have a log on both sides and we just delete the log, we're losing the potential restrictions that we haven't lost before. Okay, so now we actually have to be careful about checking to make sure that whatever we solve is actually going to work when we plug it back in. Okay, so here we go. Let's do an example. Let's start with log base 9 of x squared minus 5x equals log base 9 of 14. And you're like, oh, okay, Miss T, that seems pretty cool. I'm going to solve. Notice that I have one log on each side. So I'm going to exponentiate. All right, which means whatever's on the left side is going to turn into an exponent. Okay, my inverse property is like woo-loo, woo-loo. Okay, and we end up with x squared minus 5x equals 14. Okay, see that? When I simplify to one log each, I end up with the inside part of the log equal to each other. Now you just solve what's left. This particular case is going to take a little factoring. All right, so I have x equals 7 and x equals -2. Now I have to check. All right, look at this side here. Okay, 14 is already positive. So what I'm looking at is this part right here, and I'm making sure that this part is positive. 49 minus 35 is positive 14. Okay, yes. All right, -2. 4 plus 10. Okay, so they both work, which means there are no extraneous solutions because both of these values worked. Okay, let's go ahead and do another example. Okay, let's do, okay, oh, fancy, fancy. I like this one a lot. Log base 3 of x minus 3 equals log base 9 of 4x. Okay, here we go. Like, oh, Miss T, those bases are different. They're different. So I'm going to go ahead and you can use base 3 or base 9. I'm going to use the bigger one, okay? And I'm still going to exponentiate, okay? Because the strategy still works. And notice that inverse property that we practiced it in slightly different formats. So the left side here is whoosh. Fantastic. Just comes down to 4x. This side, just a little bit different. So we get 3 squared. Okay, so I'm going to take this 2, I'm going to bring it up here, and I'm going to work on this. Okay, oh, that's x minus 3 squared, and voila. So what I end up with is x minus 3 squared equals 4x. Okay, I exponentiated to undo the logs on both sides. Luckily, I could do that because a 3 and a 9 share the 9, right? If I look at those powers of 3, they're both there. As long as the bases are in the same set, then this exponentiation will work. So let's go ahead and FOIL and solve. Okay. Okay. X equals 9. X equals 1. So let's go back and check. Notice right here, we just have to make sure, okay, x minus 3 and 4x. So we get 6 and 36. Okay, check. Now we're going to check 1. 1 minus 3. Ooh, is negative 2. Nope. That doesn't work. X minus 3, when I try 1, does not work. So what happens is this one is called extraneous. All right, so the only solution is x equals 9. Okay, so let's recap. I had logs on both sides of the equation, and I noticed that 3 and 9 would have a common base of 3, and so I chose to exponentiate. I used 9 because I prefer this to be a whole number, right, 3 squared, and then I used my properties and I simplified to x minus 3 squared on the left and 4x on the right, and then I simplified and I solved, and then I checked. So when I checked x equals 9, it worked. When I checked x equals 1, I got a negative number. Remember, you cannot have a negative number inside the log because it's undefined. Okay, so it does not work. I didn't even try the other side because it doesn't matter. This part is undefined. So it doesn't work. So this one is a solution and this one is extraneous. All right, now that's 2 logs. Let's look at some examples that might require us to use some properties. Okay. All right. Log base 6 of x minus 2 minus 1 equals log base 6 of x. So we have two choices here, okay? And I will do this two different ways, okay? The first way is I'm going to put the logs on one side and I'm going to put the number on the other, okay? So log base 6 minus log base 6 of x equals 1. I'm going to use my property to combine this to a single log. Look at that placement. Okay, now in this case, I could exponentiate. Okay, exponentiate. Now that I'm getting good at my exponentiating, okay, right, I'm underlining the exponent. This side simplifies. And we're left with x minus 2 over x. 6 to the first is 6. Do a little cross multiply here and a little solving. And x equals negative 2 over 5. Oh, well, that's kind of funky. Let's check. All right, look at this. Can I put negative 2 over 5 here or here? Beep, beep, beep. No, I can't. Okay, it doesn't check because x minus 2, when I plug in, is negative. And so that makes this extraneous, which means I say no solution. All right. Now, I did say there was another choice, okay? This was where I combined my logs with properties. But what if I just take this, okay, watch, because you're so smart. What if I just turn the 1 into a log? What if I just turn the 1 into a log? Right? What's log base 6 of 6? 1. And now I can combine the left side into a single log. And then, look at that, exponentiate. Whew. It works out every time. Doesn't matter what kind of properties you're using, as long as you use them correctly. Oh, look at that. Beep, beep. Same equation. Okay, let's take a peek at one more equation using a property. Okay. Log base 2 of x plus log base 2 of x plus 2 equals log base 2 of x plus 6. Okay, so I have 1, 2, 3 logs. So what I would like to try and do is use my properties to condense the left side into one log. Log base 2 of x. Okay, remember the plus turns into multiplication. So we have log base 2 on the left side. On the right side, now I'm ready to exponentiate. Exponentiating doesn't really require you to rewrite the whole statement once you get the hang of it. Okay, it's much easier to fit in, so we end up with, okay, so let's solve. Okay, x equals negative 3, x equals positive 2. Okay, so I'm going to check this in green because I'm a little bit out of space. So x equals -3. So I get -3, -1, and 3. See this? I was checking this part right here. And this is negative. So this ends up being an extraneous solution. Okay, now let's check 2. Let's check +2. I get 2, 4, and 8. Yes. So the solution is x equals 2 and x equals -3, which it can't be, is extraneous. Extraneous because it did not work. Woo! Fantastic job, guys. Good luck with your assignment.